you. Nice to see those of you that I see. And nice to have you at this winter school, and also nice that you invited me to be a speaker at this winter school. I would like to talk a bit about this global software engineering in open source and its effects on quality. And what that is precisely, I come back in a second. My name is Helge. I work at IT University of Copenhagen in Denmark, and in a center that is called the Research Center for Government IT. And perhaps a bit, since you are all international, as I understand, in case you wonder about my weird accent, it comes from, the reason is that I come from a place that is called Jena. It has this, it's marked with a dot on the map. It's somewhere in the center of Germany, a smallish town. I studied there at a university that is called Friedrich Schiller University. I studied very likely what many of you are doing, also informatics or data, informatics it's called there, with a specialization in software engineering. I worked a bit there for a company that is called Intershop, producing e-commerce systems, and then eventually in 2009 I came to Denmark to write a PhD in software engineering at IT University of Copenhagen. That is actually the building that you see right behind me. After I was done with that, I was working as a software engineer for the Danish Meteorological Service or Institute. We build satellite systems or remote sensing systems, as in essence taking data from satellites that they are sending down and processing it through long pipelines until in the very end some meteorologists or scientists could do something with the data. I was mainly working on gathering data about ice in the Arctics and Antarctics. After doing that, I worked as a lecturer for 2 years for a place that is called CPH Business. And since 2019, I work as an assistant professor at IT University of Copenhagen. And I work mainly on software quality metrics, and technical data. And I hope what I'm going to tell you has an overlap to that, or with that. What my plan is to do with you today is, I understand we have 3 hours together. And I was thinking we use 1 hour to briefly discuss the paper that hopefully many of you read quickly. I was sending out some of this preparation material and I was asking, please read this paper. And then we talk, or I present a bit about branching, something that is quite central to that paper. And then my idea is actually the most important part, that the last 2 hours of that lecture we use so that you work on a mini research project where we do something very similar to that to what is done in that paper. So the idea is to do, since we are so many, that you work with each other, hopefully across continents, across countries. And then by that we generate some knowledge, we do some real software engineering research and hopefully discuss some interesting results in the end. That's the idea. That is what I would like to do. And I hope to be able to, that we are just breaks along while we are running through the course. What I would like, Aya, perhaps I would like to know first from you, can we somehow give signs of how many bachelors and how many master students you are, so that I can just get a feeling for where we are? Can we, you have this clap thing, no, or something. Can we say first all the bachelors clap? Because then I see somehow how many bachelors there are. Please clap. Wait, I don't see the chat. People seem to write in the chat. 1 second.
Yes, they are. So if you could please raise hands.
Okay.
I mean, okay. This is what you meant, right?
Yeah, there are these, you see, I'm not, you are the young people. There are these signs that you can give somehow. There's, where is it now? These actions like clapping and thumbs up. So and stuff.
There should be a list of all participants of the meeting.
Nice. Now I see that. I see that some people have raised hands. And I see that there are perhaps, from those of you who aren't, okay, perhaps I would guess a third is bachelors. Could we do the same for the masters? The masters, can you indicate how many master students we have?
Maybe anyone else has any additional things to ask? Okay, maybe you. Do you have anything to ask?
Somebody's talking who's not me. We have some PhD students, we have some postdocs. Okay, thank you for that. Okay. So thank you very much. As my strong feeling is that we are, didn't expect that, that's nice to know, that we have a similar amount of bachelor students as PhD students and some master students in between. This is how it feels to me. I hope that we can do something for all of you. And perhaps, what I would like to that you get out of that session is, in essence, how could I run a very tiny bit of software engineering research that is similar to what these Microsoft people do in their paper for me, either for me as research or for me because I work as a software engineer in some company and we need to figure out something about our development process. And this is in essence what I would like you to do, or to get out of it, how to run some scripts to gather some data, how to run some scripts to interpret the data, how to think about the data, and then how to discuss it and how to tell your colleagues about, I think this and that is true for us. And this is in essence what I would like you to get out of the course. Cool. I think many of you at least read this paper, The Effect of Branching Strategies on Software Quality, by what I would pronounce as Shihab and some colleagues. What is it? And please just talk to me. Please don't write to this chat. Just please talk to me as we were in a normal session. I would like to know, what is it that you got out of that paper? So what is it you think the message is?
The most important thing that I take is that branching take mass effect on quality of software, and this is important to take right strategy in branching and study it.
Thank you. I'm just trying to write something. As you see now, you have live with my weird handwriting. And somebody, unfortunately, I could not see your name. Thank you. Somebody said, it seems that branching has an effect to software quality, actually. Thank you for that. That is nice. Is there anybody else? Thank you, Vladislav. Thank you.
Yes, I'd also like to add something. So I think the main idea was that it's not the branching itself that creates flaws in software, but primarily the communication errors and like the errors in the processes associated with the branching. Nice,
thank you, Valeria. Thank you. I hear that it's not the technical thing. How to write it down? Not technical branching is the issue, but I would call the human work or the human processes behind it. This is what I understand you saying.
Yes, exactly.
That's a nice observation. We as humans build software. Anything else?
Yes, can I answer?
Yeah.
Yeah, so when I read the paper, I got the feeling that branching was something that you sort of expected, that this is something you need to do in these projects, but that you haven't perhaps evaluated how you should do the branching. And that was something that they found as an issue, that we haven't really evaluated how the branching should be done. And then when they evaluated, they of course found that, oh, well, this has a very big impact on, the quality, how we branch and different ways of branching, let's say. So I find it quite interesting that for something that was kind of, let's say, taken for granted, that there was such a huge difference once they actually made some effort to analyze it.
Thank you. I'm just writing while I listen to you. Thank you, Johan. What I try to write down in my bad handwriting, it's on a device, that we somehow take branching for granted. Everybody thinks, yes, we just branch. but obviously there seem to be different ways of branching, and obviously they work differently well or not. And suddenly people look at how well do they actually work. That's nice. Yeah. Thank you very much. Is there, let me quickly check, sorry. Where is my cursor? Yeah. Is there anything else that somebody else would like to add?
I thought it was.
Yeah.
Do you want to go? Yeah. Okay.
Please go, one of you. I cannot see you for some reason.
I'm sorry, I don't have a camera on my PC here.
And it, yeah, cool.
Yeah. So I thought it was interesting that in the paper they showed that the impact of organizational mismatch in the branching organization is statistically more impacting the quality than organizing it depending on the software architecture. I thought that's interesting. Like communication, social factors seem to play a bigger role actually for the quality.
Okay, as a branching along organization, and that is important, just to understand you right, branching along the organization is better or worse for quality?
If I remember correctly, the result was that it has a better, how can I say, a mismatch in organizational structuring has a bigger impact on the quality than a mismatch in software architecture organization.
Also, I also have to take my, sorry, 1 second. Yeah, thank you. Now I don't have the paper open, but it says something along the lines what you said. Thank you. That when you branch along organization, it generates more defects, and I check with the paper again, than when you branch along the architecture. And please correct me if I'm wrong, because now, where's the paper? Let me quickly scroll down in the paper.
It was pretty late when I read it, but I thought it was the other way around.
Exactly, and you see, I just read it right before we started again, just to be on the same side, to say the proper thing, but I always get it wrong. It says organizational structure has a stronger relationship with failure than architectural mismatch. This is what it says. Thank you very much.
Overly complex branching structures negatively affect software quality. This is go all right through the wallpaper. There is a lot said about information theory, and that we must keep everything in hands, under control, because the more branch is not always the good. There is a lot of troubles with merging, and scattering is bad.
The deeper branches, and I don't know what's going on here, and the more scattered changes, the worse. Cool. Thank you very much. I think these are super nice observations. So thank you for your feedback, and thank you for the brief discussion. And perhaps let's before I continue, let's get one thing right. Do you remember what those authors say? What software quality actually is for them? Because we say that one of the first observations is that yes, branching, as how we branch or the amount of how we branch has an effect on software quality. But what was that actually, software quality?
They measure the success of some branching strategy depending on quantity of failures after release.
Thank you. The quantity or the number of post-release failures. And this is actually what they say. As for us, quality is something really, really narrow. A number of how many post-release failures we have. What is that actually a post-release failure? Or what is it that they take as a post-release failure?
The numbers of fixes, maybe, I don't remember correctly.
The number of fixes, and they take that indirectly. They say something, I don't remember where, somewhere in the method section, they say that they use a central artifact of their software engineering process to get post-release failures. You see, as I also remember things bad always. They take, in essence, they talk about.
Wait. Something like a count of failures dividing by count of lines added.
That's true. They say which kind of metrics they compute. As they say something exactly as you said. As they talk about ratios of number of failures divided by number of development commits or something. But in essence, what they are doing is they have a central artifact. They have at Microsoft, obviously, like in many other companies or organizations, they have this issue tracker, and they use the data from the issue tracker. So we don't really know how these issues come in there, as if it is really end users writing them in, or if it is going through their help desk, or what do I know? Anyways, they have an issue tracker, and they say the MP3 player is breaking. When I play this song, then it crashes, something like that. And they take this information and say, now what we have in the issue tracker, we count that as a post-release failure. Also these reports there. Cool. This is something just to keep in mind. And I don't want to say with my talk here that software quality is number of failures per se. It's only for these people in that piece of research. And what some other people also do is somehow the number of bugs is strongly linked to software quality. As often it's said to be software quality. But there are many other things. As of course, there are things like reliability, as you heard before with the one, what do I know, dependability, maintainability. As there are many other qualities that all can be mentioned, but those people say one really narrow piece of software quality. Apropos, I see in the chat people sending links to my presentation, and actually it's take this one here. The link that you were sending before is to a lecture that is very similar, but for another course. So I changed some slides here. So if you want to scroll along with me, you can look at these slides. Cool.
I'm sorry, you have text above your search bar.
I pasted it to the chat. Let me quickly clean the slide so that I can continue. Nice. Thank you for your observations. I think we gathered the key results in the observations, and this was namely that at Microsoft there seems to be a relation between how we branch and according to which structures, as organizational structure or architectural structure, and the number of post-release defects, and many more things, as like what you mentioned, as they have these different hypotheses, as about branch scattering also and stuff. So they, in essence, one thing that I would like you to observe is these people in their research, they have a lot of different hypotheses what could be somehow related to bugs or post-release failures, and then they check, is there a correlation to that? And for some things, in case of Windows, Vista and Windows 7, they find these relations. Super. I think that was actually what I had in mind. And what I would really like you to focus on is what we are going to do in the remainder, or in the second part of the section, is we focus on that. As we focus on this slim thing, branching and defects? Is there a correlation? This is what we are interested in the second part of the session. Cool. Is there anything, you see, as now that I was imagine we are not at universities, imagine you study, you work somewhere as a software engineer, you're done studying, and I'm your boss and I say, hey, I want to know that too, that at Microsoft, they seem to have issues when they branch, or when they branch in a certain way, that it seems like they generate more bugs in the end. Is there anything that you could think about as now I was your boss? I wanted to say, I read this paper, look at it. I want to know that thing too for us. Does it hold for our company? Could you do that? Also, would you be able, by reading the paper, to say, Naya, I generate that data for us and I generate these correlations?
I think this depends heavily on company you're working in.
Mm-hmm. Yeah, why that? Also what is
because strategy will depend on the size of your code base company, and the same thing will not work twice for different projects.
Nice. As there is this observation that very likely there is some relation to the size of the organization, as very likely certain effects that they report, you very likely first meet from not having as many people, also because they say they have this organization chart and they map which roles report to who. By that they know what are teams, and by that they suddenly know, do these people branch across team structures or not. Also, that is something that, of course, when you work with 5 friends and you just started a small company, you don't have that. You all know each other. That is true. Is there something else? Also, practically.
Well, you can as well collect statistics and take research about your own company, your efficiency, and try to do the same thing, but it will be very time consuming.
Nice. It will be very time consuming. That is true. And I hope that we can press something like that in the second 2 hours. It's true, it's time consuming, but I'm more interested in something way more concrete. You see, also these people say they write, we check something for Windows Vista and we check something for Windows 7, and they talk about their version control system. Do you know what kind of version control system they use and how they get data out of there? I see some people of you shaking heads. Exactly. Something that we just don't know by reading the paper. It is implicit, the knowledge of how do they actually work together, technically, what is the version control system that they use to send their changes back and forth or to work together. We don't really know how branching in that version control system works. Since they are Microsoft, they very likely have some proprietary in-house version control system. And since we are not Microsoft, we don't have that. So what you can see in research, and what we are also going to do in the remainder of the section, we look at one particular version control system, and that is Git, just because many people are using it and it seems to be the most popular at the moment. But that is actually, I think, a really central observation to see, I don't really know how I get this information about when a branch is a branch out of that, out of the version control system. Another thing that you very likely to have the paper. Another thing that very likely is, I think, that is only implicitly given is they talk about this concept of branch families. And this is something that seems to be also inherent to their version control system. So somehow they can do that. They can group certain branches together. They can say, now, these things are all about, as what I know, as an MP3 player audio stuff. Or perhaps here in the bottom, it's all about image processing stuff. In many other version control systems, especially in Git, you cannot do that directly. So we come to branches, as you branch by name, and this information is somehow lost. Cool. There's another thing I think that is only there implicit that should be observed, and it is what kind of issue tracker do they use? How do they get this information practically from that issue tracker about failure reports out of that issue tracker? We just don't know. As we don't know what issue tracker they have, and we also don't know what precisely they collect as bugs or post-release failures out of that. So this is something that I would like you to realize for, as especially the bachelor's and master's students, for your own, when you write your thesis. Perhaps this is information that is good to share with the reader. How precisely did I do that thing? Where does my information come from? Where does it go to? I don't know, in Danish, what we are doing, informatics, is often called literally translated to English, electronic data treatment. This is a bit of an old school term, but I think that very well describes what we are doing as software engineers. No matter what, we treat data electronically. And as a researcher or as a student, you very likely want to keep it that way and also describe what is the kind of data that I get, how do I process it, and what data do I get out of it, as the standard input-output data processing model. And this is also very good to apply for reporting your results or to write when you write your thesis or any other paper. Nice. Let me quickly walk through what I would like you to do, and we do a bit of what is branching actually in that case on Git before you do something. As said, we will have a look at one version control system, and this is Git. And the reason is it's open and we can quickly find a lot of systems or a lot of projects that use it. A branch in Git, if I link you on the next slide to a book down here, and it's actually, I think, your favorite reference when working with Git, also when using it, but also when understanding it. And it's this Pro Git book. In essence, they give you these illustrations and they tell you that what Git does is it takes snapshots of data, as you have your files lying in your file system, and you say git add. And when you do that, it takes a snapshot and it takes what is here in these yellow bubbles. It says, now I take the text file, I open it, I hash it, I put all these things together in what is called here a tree object, as a snapshot of the state that I'm currently looking on. And once you say git commit, one of these git commit objects is created, and everything here is hashed, as you can see. And these are always these weird numbers that you deal with when you work with Git. And this is how Git commit objects are stored, as snapshots of data, not as deltas between different states. Other version control systems do it like that. Very likely what they used in the Microsoft case stores deltas. But Git uses another principle as a snapshot. Every time the new state, complete files, no deltas between. To understand what a branch is, we first have to look at how Git organizes history. And you can see what you very likely know when you look with git log at your commit history is that commits always refer to the previous commit. As you can see here in this illustration, that commits always point to their parent. And they do that by pointing to their hash. As you can see, this hash number is used here. And each commit is a state, a state in time of the entire data that you have in your directory lying around. And I see people, I got confused because I see people in the chat saying blockchain, and this is in essence the same idea as blockchain, like exactly as the data structure behind it is called a Merkle tree. If you want to, you Google it up, and this is just about we hash everything and then we point by hashes to hashes, and by that we always know what points to each other. There's something important to see. There are different kinds of commits. The very first commit, as you can see here in your history, doesn't have a parent, of course. The parent field is empty, because what would it be? A normal commit has one parent. You just continue walking through history. A merging commit, where you take two branches, for example, and you say, I make one out of it, points to multiple parents. That is not illustrated here. But a merging commit, important to remember, has multiple parents. It can be 2, but you can also merge more branches. So what is a branch now really? A branch in Git is nothing really special. A branch in Git is really just what they call a pointer, as it's really just a piece of a piece of text somewhere in a file that points to a certain hash number, also to a certain commit hash. And this is what you can see here. You can see, for example, that your master branch, where head is pointing to, as what you're currently working on or looking at, is in this state, as that commit. And you can see that there is another commit, and there's a pointer to that other commit in a testing branch. And that is really how Git organizes this information internally. So there are just some text strings that point to commit hashes. And these are actually branches. As these 2 things, the master branch and the testing branch, are just text pointers to commit hashes. That's it. And you can see that once you continue committing, as for example, here you work in your master branch that you're currently looking at, you create a new commit, and then suddenly branches look like as a branchy. That's it. As a branch in Git is something really lightweight. In other version control systems, branches are complete copies. As for example, in Mercurial, a branch, as you branch by copying an entire directory, and then you have a branch. And in Git, it's not like that. So in Git, you branch by just checking out certain commits, and then you know I'm looking at that one. Nice. I'll quickly walk you through some, or I just give you a brief overview of that there are different branching strategies, and then I'll talk a bit about the research that I would like you to do. There's this quote from a paper, Branching and Merging and Investigation into Current Version Control Practices, and there they asked some practitioners about, now how do you have it actually with branching, or with using version control systems that allow for this branching idea. And they say, no, we're actually quite old. I forgot, I think they're around 50 or what? I know, they're all 40, and they work long as software engineers. And they all say, you see, as a branching is easy enough, we just take, but it really gets hairy when we have to merge something. And very likely this is something that you all know now, as merging something can get quite difficult as soon when you get a change that is big enough and that is like what they describe distributed over multiple files. And what you see, as there's this branching strategy that is called long-running branches. And what you do there, you can see that in some organizations and also in some repositories that you very likely see at GitHub, is that people branch off their master branch and work on something, and then they decide on, now from that state I work again on something else. And you can see that these branches are in essence, as you can see in the illustration, just continuous history, but by introducing these pointers, they suddenly appear as branches. Then many people work what is called on topic branches. As you say, now I have one concern now, I want to fix that bug, I want to introduce this new feature, I want to work on this and that small thing during the day. And for that, I create a branch, I do my work, and I merge it back at the end of the day, or even quicker. So the idea is really small pieces of work, you branch off and you merge back in. And this is just an illustration of that. Something that got quite popular in the recent years is this thing that is called Git Flow, and it somehow mixes the previous two. So where you say, now we have this, we have, for example, a master branch and a development branch, and in between we have something like, you see hotfix branches or release branches, and then here we have feature branches, also these topics things. Here we do our daily work in essence on the yellow line, and every now and then, as from our main development branch, we branch off for releases that we are doing, and in between we can do hot fixes on the master branch directly. I can see that people are discussing master branch in the chat. I just use master branch because this is how Git still calls it internally. As a default branch name, as branches can be called anything, but default Git calls it still master. Eventually they will change it. And I don't want to be rude towards anybody. This is the main reason, as just because it's called like that in the tool. And GitHub just at the moment tells you to rename your master branch into main branch and set another default branch name. And this is what they do. But Git, the tool itself internally, still calls it like that. So no offense, please. As in essence, my point here is Git flow is somehow a mix between the previous two long-running branches and feature branches. Then you have people like Google that say, nah, we don't branch at all, actually. And they do the opposite. As they say, we don't have our main branch or master branch and take releases from it, as we just saw in Git flow. They say we do the opposite. We all develop constantly on the they call it trunk, as very likely they don't use Git, but something else. So on the master branch, everybody works there constantly, and then we have releases of something that we branch off. And when those releases should be fixed for something or what, then they describe in their book that they have people, release managers or group managers, they can cherry pick out of the main branch what they want to have in their releases. So for example, bug fixes or what. So in essence, my point is different organizations, as you observed earlier, and as you also said, that different organizations branch really differently. As not only does Microsoft branch differently within the organization, but in essence, everybody uses different strategies. And the question is, which of those that we just saw do the Microsoft people use actually? Do they use long-running branches, feature branches, Git flow, trunk-based development? I take the silence as we don't know. I'm sorry. I hope I get you again. As in essence, we don't know. As I was just presenting different branching models that people are using, especially with Git. And in essence, the Microsoft people seem to use yet another branching strategy. As not one of the ones presented, but yet another one. And you can see, as they describe in essence, those that they branch along organization and they branch along architecture. Let's do something practically, because you see, obviously I lost you a bit. I would like you to do something for the rest of the time. And before we take a break, I would like to walk you through what I would like you to do. And I hope that is fun. In essence, I would like that we work on their main finding. As you see, Shihab and all say, we find that there's indeed an effect of branching on software quality. And I would like that we figure out until 5 my time and 7 Moscow time, or what, that we figure out, is that true for certain open source systems too? Does it hold or not? Because they do it on Windows 7 and Windows Vista. That seems to be true. Is that true for open source systems too? There is a difference, very likely, to how these open source systems are developed compared to how Microsoft develops. And many of them are very likely distributed developed in an even more distributed way. As we are now in the lecture, that people from everywhere in the world contribute to a system. And that might actually lead us to different results. As very likely, Microsoft has more control over the organization, and by that they can enforce certain working practices more. And the question in essence is, Microsoft says there is a relation. Do we find the same thing for open source? For that, I formulate this research question: is there a correlation between branching activity and software quality? This is what I would like us to work on for the rest of the time in open source software. And for branching activity, as in essence, we look at their first hypothesis only. As they do a lot of stuff and we narrow it down, we do something really precise as one thing. And for branching activity, I would like that we consider the same as what they are doing, and that we use merging commits as proxies for branching activity. And you can see if you read their paper, this is actually what they are doing. They don't measure how often is there branched, they measure how often is there merged. And I would like us to do the same, and the main reason is actually that for the Git version control system that organizes branches like that, we don't really know when there is branched really. Also because you see, as branches are just these slim pointers to some commits. And as this illustration shows, those pointers to certain commits of branches, they can be called anything. And especially they can get deleted once we merge branches. So then we don't really know anymore, as you see, was this thing, was it 4 branches, was it 5 branches, or was it actually just one as it is displayed? As once things are merged, we don't really know that anymore. And this is the reason why I would like that we consider merges as proxies for branching activity, the same way as the researchers from Microsoft do. So, and the same way as they are doing, I would like that we work on issue tracker data. And I would say we take everything that is labeled a bug in an issue tracker, we consider that a post-release failure, or just they call it a post-release failure. We say everything that is in an issue tracker and has the bug label is a defect for us. And we say that is a proxy for software quality. The more bug reports in an issue tracker, the worse the software quality of that thing. Cool. What do we need to investigate our research question? Also our research question, is there a correlation between branching activity and software quality? I think we need 4 things. Let's brainstorm quickly. What do we need?
Data.
Merge history.
Niceness. We need data on merge history.
Data on bugs.
Data on bugs. Niceness. Where as
issues history.
Sorry.
Issues history.
Issue history as a data on bugs. We take them together. Exactly.
Maybe you can take also the size of the repository because like it will depend on. I mean, the final result will depend on this as well.
Niceness. We keep that in the back of our mind, what you just suggested, and we come back to that in the discussion in the end. We could take what the people from Microsoft say, they have some controlling, as they control for certain metrics, like size and complexity, because they say we know from other work, now the bigger something is and the more complex something is, the more bugs are in there. So we control that out of our data. So yes, we could take that. Yeah.
Another thing are the number of branches initially created, because I mean, like one aspect is like many times the project is not big, but due to certain large number of branches, the complexity increases, like a curse of dimensionality.
Yeah, nice. Also the number of branches, and we take the number of branches as I tried to indicate. We search for, as we need the history of the project. By that, by having the merge commits, we have a proxy for the number of branches. We don't have a proxy for the number of open branches, but only for branches that were there before in time. Yeah. I would say we need 2 things more.
We need a statistical approach to verify our question.
Nice. We need something to, as we ask for a correlation, we need some statistical tests so that we can compute correlations between merges and bugs. There's still one thing missing.
Maybe metric.
on which we can conduct our research.
Sorry, say that again.
Software systems on which we.
Niceness.
Oh,
Niceness.
okay.
We need systems. As we need, you see those people from Microsoft, they say, hey, we do Windows 7, Windows Vista. We need something similar. We need just as a case systems. We need software on which we conduct our research. So if you were to work somewhere, this very likely would be the software that you produce. But now, since we are in a lecture and we don't produce software, we take some open source systems and say on that. And this is exactly what we are doing. We take some case systems. So we are running a case study. And we take only systems from the Apache Software Foundation, because I know they are there and this is what I prepared. And we take, since you are many people, I don't see how many you are at the moment, but you're more than 100 people. So I would guess we work in many, many groups. So we take at least very likely 40 systems, around 40 systems. And I put a list of systems in here. And for the moment, it's not really, since we only have a short amount of time, it doesn't really matter what these systems do, but they all do real, as they are proper software systems, they solve certain issues. One reason more why we use these systems from Apache is because many or most of them organize their issues in the Jira issue tracker, and they host an open instance, so we can collect data from that. And sorry, what I forgot to say, what I would like is that we collect the number of merge commits per week from the histories of these projects. And sorry, and the number of bug reports or defect reports per week. So everything that I think we should collect is, or that we should compare are number of merge commits per week versus a number of bug reports per week. Cool. And the last thing is we need, as it was said, some statistical tests. And we also, I think we want to plot some data, because before we do statistical tests, we would like to see some plots, because then we already get a feeling for, is there a correlation or not? As we do this visual inspection thing. And so we need the ability to plot data as a number of bug reports per week versus number of merge commits per week. This will be a scatter plot. And then we need a correlation measure. And we are going to use Spearman's rho as a correlation coefficient. And in the discussion, I come back to why I believe that's a good one. So we need these four things: case systems, defect reports from Jira, version control system history from GitHub or from Git hosted on GitHub. And we compute Spearman's rho and we plot scatter plots. Nice. What I would like you to do is, during that work, is that you build in Essence small modules for which I provide code blocks. And before the break, I walk you through the code blocks and then we start the project. So we need to build a small module that can pull down data from Jira. We need a small complement that can collect version control system data from version control system. And we need a small module that can combine these two and plot and compute correlations. In essence, what you can do with these hosted Jira instances of Apache is that you can send HTTP GET requests. So here's an example with curl to say, for example, a Airflow project. This is here, Airflow. Give me all your tickets. And by, for example, issue type, as you filter here with issue type names for bugs, you say, hey, give me all bug reports. I want to have all your bug reports that are stored in here. And you get a lot of other data that we don't really need. My point is, we can send a web request to collect some data from the issue tracker. This is how it would look like with curl. And that should actually, as you should be able to run that from your command line. Or we could do that, everything that I provide you as examples are small Python code stumps. And in Python, using the requests module, we would use this long URL. You have to point to a certain project, which in that case could be Airflow or any of this long list. And we send the request away, sending an HTTP GET request. we get some data back, and that you can see is actually JSON data that we can then unparse and interpret for the data that we need. Cool. This is how we could collect defect reports from Jira via web requests. The version control history, version control system history from each of these Apache systems, we could either get that and unparse it and interpret it by using the git log command directly. As first we clone, for example, the Apache Airflow project, and then in the Apache Airflow repository that we just cloned, we said, now show me the log of that thing, and then we unparse that. We could do that, but then we have to do quite a bit of text parsing. And this is why we could use some Python module that is called PyDriller that actually nicely wraps working over Git histories. So there you could, for example, say, hey, I have this Apache project, in that case Airflow, and PyDriller, please clone that thing for me. This is what this class does for you implicitly. It clones that project. And then you can traverse all commits. And for example, here it just shows you how to print out all commit hashes that are in the history. So this is a code block that you might want to reuse. What I would like you to do is that these two modules, they do something that we often do when we do research. We just generate here comma-separated value files. As we translate this JSON data that we get from here into a CSV file that you can see has an issue ID, certain information, as when it was created, when it was opened, and the attached version and stuff. This creation date is actually the most important thing, because by that we want to group in how many things were there created per week, so how many bugs were there created per week. The same thing for the version control data, as we could generate a CSV file that maps or that just stores commit hashes and the times of commits, or the commit creation dates or timestamps. And again, we can use these to group how many merge commits were there per week. And actually, these are only merge commits. So, and then the third module just takes these two, does actually this grouping that I just mentioned, also that we group per how many bug reports do we have per week, how many merge commits do we have per week, and then we can plot those and compute a Spearman's rule on that. And if we had this data, this is a bit of code that would show you how you could plot that. So if you had on your x-axis the number of merges per week, or on the y-axis the number of defects per week, you could say, hey, Python, create me a scatter plot, save that file, and it would look something like that. If you wanted to compute Spearman's row, there's under SciPy in the stats module, there is a Spearman's row implementation that you can just feed that data, and it will tell you a correlation number and the corresponding p-value. So for each of these things, I think I link to documentation. And perhaps let's say we take a 10 minutes break, and after that I walk you through what I really would like you to do, also how precisely I would like you to do that. And then you organize the rest of the breaks on the way. Let's say perhaps at 5 past, I'm here again.